Good morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about memory organization. So, what is memory organization? The memory unit is an essential component in any digital computer since it is needed for storing programs and data. A very small computer with a limited application may be able to fulfill its intended task without the need of additional storage capacity. Most general purpose computers would run more efficiently if they were equipped with additional storage beyond the capacity of the main memory. And it is more economical to use low cost storage devices to serve as a backup for storing the information that is not currently used by the CPU. So what is a memory organization? So there are different types of memories are there in a computer. So all those are related to the CPU, central processing unit. So how many types of memories and how it is useful to the CPU, that is the important. So here memory organization means, suppose I need a main memory and I need externally connected to the CPU. So peripheral devices I need. So how we are using? So memory is mainly using for storing the programs or data in a computer. So the memory unit is an essential component in a digital computer because memory is always a hardware device. It is always a hardware device. So a very small computer with a limited application may be able to fulfill its intended task without the need of additional storage capacity. So suppose I have the CPU. For the CPU, memory is connected. So in this memory, we need an intended without the additional storage capacity. Inbuilt memory, what is that means? That is the storage capacity. That is the additional. We don't need of any additional. If we need additional storage capacity, externally we are connecting memory to the CPU. That is called secondary memory. And most general purpose computers would run more efficiently if they were equipped with additional storage beyond the capacity of the main memory. So what is the inbuilt memory? That is the main memory. And what is the additional storage we need? That is called secondary storage and also called auxiliary memory. And it is more economical to use low cost storage devices to serve as a backup for storing the information that is not currently used by the CPU. So suppose I'm taking for the memory. Already we know that CPU internally connected to the memory and it is a central processing unit or control unit. So all should be connected together. It is the input and output. So any of the computer we need CPU. CPU is internally connected to the memory and control unit. So between the CPU and memory we need some buses. So what are the buses means? Data bus, address bus and control bus. So control bus means control unit will manage all those things, but we need a CPU for this one. So CPU means central processing unit. It is connected to the memory. Okay. So these are interconnected to the CPU and memory. So how many types of memory? Is it important? As the CPU is internally connected to the CPU, and these are very important for this one. And when we are going for the memory hierarchy, the memory unit that communicates directly with the CPU is called the main memory. Devices that provide backup storage are called auxiliary memory. The most common auxiliary memory devices used in computer system are magnetic disk and magnetic tapes. They are used for storing system programs, large data files, and other backup information. Only programs and data currently needed by the processor reside in main memory. All other information is stored in auxiliary memory and transferred to main memory when needed. So what is a memory hierarchy? Memory hierarchy means how many types of memories are used in a CPU. So what is the inbuilt memory is there? That is called main memory. So always main memory is connected to the CPU. It is connected to the CPU. So if you need additional memory to the CPU, that is called auxiliary memory. So the most common auxiliary memory devices are computer systems are magnetic disk and magnetic tape. These are the most important and mostly used in a CPU. That is called auxiliary memories, means externally connected memories to the CPU. So we are additionally using this memory to the CPU. So they are used for storing system programs, large data files, and other backup information. Only programs and data currently needed by the processor reside in main memory. All other information is stored in auxiliary and transferred to the main memory when needed. So magnetic tape and magnetic disks are the additional memories. Or the additional memories are connected to the CPU. So these are also called auxiliary memory. Auxiliary memory. So those are storing systems in the program, large data files, and other backup information. Only programs and data currently needed by the processor and reside the main memory. All the other information is stored in auxiliary memory and transferred to the main memory when needed. Okay, so what is processing is going on means, suppose CPU, main memory, and it is the auxiliary memory. So this auxiliary memory is the additional memory. So when the data is transferring to the auxiliary memory, it is transferred to the main memory, then it is going to the CPU. So if CPU will transfer the data, then CPU to main memory, and then main memory to auxiliary memory. So here main memory is a mediator between the CPU and auxiliary memory. So any data any data transferred to CPU from auxiliary memory from auxiliary memory through the main memory only it is possible. Through the main memory will pass the data. So any of the information through the auxiliary memory, so it will pass to the main memory, then only it will go to the CPU. If CPU will give the information to the auxiliary memory, or any data passing to the auxiliary CPU to auxiliary through the main memory only it is possible. So it is the additional memory is used in CPU. So the storage of the program and large data files and other backup information, only programs and data currently needed by the processor reside in main memory. All other information is stored in auxiliary memory and transferred to the main memory is when needed it is possible. And the memory hierarchy system consists of all storage devices employed in a computer system, from the slow but high capacity auxiliary memory to a relatively faster main memory to an even smaller and faster cache memory accessible to the high-speed processing unit. So here I'm taking one block diagram. How many types of memories are there? Here, first one is a register memory, cache memory, main memory, magnetic disk, magnetic tape. So magnetic disk and magnetic tape are called the auxiliary memories, means external externally connected externally connected to the CPU or main memory. So primary memory is a main memory, secondary memory is a auxiliary memory. So always primary memory is called main memory, but means inbuilt memory is connected to the CPU. Inbuilt it is designed. And magnetic disk, magnetic tape are the externally connected to the CPU or main memory. That is the auxiliary memory. And the cache memory is also connected to the CPU through the main memory and register memory. These are the types of memories are there. So what is the access ratio? Increasing order. Here bottom to top, increasing order. So what is the increasing order of time access means? Magnetic tape, magnetic disk, main memory, cache like this. Okay. What are the properties of memories? Storage capacity, cost per bit, access speed. For this purpose, we are using memories. Okay. So which one is the fastest? One means register memory is a fast and the cache memory is better, and the main memory is somewhat better, and the magnetic disk, magnetic tape are the very slow compared to main memory and the cache memory. Why? Because we are connected externally to the main memory, so the data transferred to the CPU or main memory to externally means magnetic disk and magnetic tape are somewhat cost is reduced, but time will take more time to access or to transfer the data. So when I'm using the cache memory between the main memory to CPU, when I'm using cache memory, if I'm using CPU to main memory, and other diagram, if I'm using CPU with cache memory with main memory, with main memory, is it any difference? Yes, it is. The main memory to CPU, the data will be transferred, but here main memory is directly not transferring the data to the CPU. It is main memory to CPU, cache memory to memory. Why? Because compared to main memory, cache memory data transfer rate is high, and time will be reduced when we are transferring the data to the CPU to main memory. So that is the reason we are in the cache memory between between the main memory and CPU. The cache memory is connected to this one. Here register memory, cache memory. So between the CPU and main memory, cache memory is connected. Magnetic disk, magnetic tape are externally connected. Those are called secondary memory or auxiliary memory. So for this consisting of storage devices, a computer system from the slow but high capacity auxiliary memory to a relatively fast main memory to even smaller and faster cache memory accessible to high speed processing logic. So storage capacity, cost per bit, access speed are the properties of the main memory. So here I am using registers. So what is the use of registers? It is also memory. It is also memory like 8-bit, 16-bit like this. But here what is the use of register means? Transfer data, transfer data between the memory, between the memory and CPU. So registers are the 8-bit or 16-bit small amount of data will be transferred between the memory and CPU. And here memory hierarchy in a computer system. So what is the auxiliary memory? Auxiliary memories here I am taking two types. First one is a magnetic tape. Second one is a magnetic disk. So these magnetic tape and magnetic disk are connected to the input output processor. Why? Because these are externally connected to the CPU. Externally connecting. Externally connecting. So that is the reason we are calling as these are the input output ports. So magnetic tape, magnetic disk are connected to the input output processor. So externally connected to the input output ports, and main memory, cache memory are directly connected to the CPU. So you can see here main memory is directly connected to CPU, cache memory also connected to CPU. So if I don't want cache memory, so CPU directly transfer the CPU to main memory and main memory to CPU. If I need cache memory, then main memory to cache memory to CPU. So cache memory is in between the main memory and CPU. So cache memory is a mediator. It is not a mandatory. If we need, suppose in the less time, more data should be transferred. So cache memory is that, and it will be, if I'm using cache memory, then the burden of CPU will be less. Okay, so that is the reason we are connecting cache memory. So CPU, from CPU, main memory and cache memory directly connected to the CPU of main memory and cache memory. But what about the magnetic tape and magnetic disk? These are not directly connected to the CPU. Why? Because these are the externally connected. Okay, so additional memory to the main memory, additional memory to the main memory. So that is the reason this main memory is connected to the input output through the input output ports. So secondary memory secondary memory is connected to the primary memory. So secondary memory is directly connected to the primary memory. Then only this primary memory is connected to the CPU. But always cache memory and main memory is connected directly to the CPU. But secondary memory or auxiliary memory is connected to the main memory. Then only it is connected to the CPU. And the main memory occupies a central position by being able to communicate directly with the CPU and with auxiliary memory devices through an input-output processor. When programs not residing in main memory are needed by the CPU, they are brought in from auxiliary from memory. Programs not currently needed in main memory are transferred to auxiliary memory to provide space for currently used programs and data. A special very high-speed memory called a cache is sometimes used to increase the speed of processing by making current program and data available to the CPU at a rapid rate. The cache memory is employed in computer system to compensate for the speed differential between main memory access time and processor logic. So when I am using main memory, when I am using auxiliary, and when I am using cache memory, that is a discussion. And the main memory occupies a central position by being able to communicate directly with the CPU and auxiliary memory devices through an input-output processor. So CPU will directly access to the main memory and cache memory. But auxiliary or secondary will directly access to input-output. Then only it is connected to the main memory. So when programs not residing in the main memory are needed by the CPU, they brought in from the auxiliary memory. Programs not currently needed in main memory are transferred into auxiliary memory to provide space for currently used programs and data. When main memory is not available to the CPU to execute the program, when we are using secondary memory connected to the main memory to execute the program. And a special very high speed memory called cache memory. It is a very important role for the CPU or main memory. It is a very high speed memory and sometimes used to increase the speed of processor by making current program and data available in the CPU in the rapid rate. In the less time, more data should be transferred. That is a rapid rate. The data transfer rate will be increasing when I'm using cache memory. So it is not a mandatory to connect between the CPU and memory, but when I need, we'll connect. The cache memory is employed in computer system to compensate for the speed differential between the main memory access time and the processor logic. CPU logic is usually faster than the main memory access time, with the result that processing speed is limited primarily by the speed of main memory. A technique used to compensate for the mismatch in operating speed is to employ in externally fast small cache between the CPU and main memory whose access time is close to the processor and the logic clock cycle time. As the storage capacity of the memory increases, the cost per bit of the storing binary information decrease, the access time of the memory becomes longer. So when I'm using the CPU logic, the main memory is the fastest access time when the result of the processor speed of the primary of the speed of the main memory. A technique used to compensate for the mismatch in operating speed to externally fast small cache between the CPU and main memory to decrease the access time and close to processor logic clock time. So when I'm using cache Then what will improve? Access time should be decrease and improve the data rate. Data rate should be improved. So when the storage capacity of the memory increases, the cost per bit for the storing binary information decreases. So when I'm using the capacity of the main memory increasing, when I'm increasing the main memory, then cost also increasing. So if I'm using the cache memory, the cost will be increased, but memory increasing, the cost per bit of the storing the information will be decreases, and access time of the memory becomes longer. Access time also longer. So that is the reason we are using cache memory to reduce the cost and reduce the time. The overall goal of using a memory hierarchy is to obtain the highest possible average access speed while minimizing the total cost of the entire memory system. Auxiliary and cache memories are used for different purposes. The cache holds those parts of the program and data that are most heavily used, while the auxiliary memory holds those parts that are not presently used by the CPU. Moreover, the CPU has direct access to both cache and memory, but not to auxiliary memory. The transfer from auxiliary to main memory is usually done by means of direct memory access to a larger blocks of data. The typical access time ratio between the cache and memory is about 1 to 7. So when I'm using main memory, when we are using cache memory, when we using auxiliary memory, what will happen? So the overall goal to use the memory hierarchy. So which type of memory you are using to execute the program, that is the important, and the highest possible average access speed of the minimizing the total cost of the entire memory. So when you are using the memory, which type of memory you can use, but what is the main thing is the what about the cost, what about the time, what about the data. Cost, we have to decrease the cost, time, and improve the data rate. That is the important. Auxiliary and cache memories are used for different purposes. Auxiliary concept is different, cache memory is different, but the cache holds those parts of the program and the data that are most heavily used. Cache is nothing but it is holds the data between, it will be executing between the main memory and the CPU only. But auxiliary memory is the main memory. Auxiliary is the data passing through the main memory. The CPU has direct access both the cache and memory, but not auxiliary. The transfer from auxiliary to main memory is usually done by means of direct memory access. So when primary memory to primary to secondary direct memory access is using, the transfer from auxiliary to main memory usually done by means of direct memory access by larger blocks of data. More data is there, then I'm using DMA. And DMA means direct memory access, means no need of any CPU. CPU will be disabled. And the typical access time ratio between the cache memory is about 1 to 7. And for example, if I am taking typical cache memory may have the access time is 100 nanoseconds. If I'm using this cache memory, what is the time is 100 nanoseconds. While main memory access time may be 700 nanoseconds. Same data, cache memory is using 100 nanoseconds. Same data, main memory is taking 700 nanoseconds. But same data, auxiliary memory access time is 1000 times that of main memory. Means how much time we need for auxiliary memory. So compared to these, which one is better means cache memory is using. Why? Because less time is occupying and more data transfer rate is there. And block sizes of auxiliary memory ranges from 256 to 2048, 2048 watts when I'm using auxiliary. But cache block size is 1 to 16 watts. So it is a drawback, means 1 to 16 only. But here 256 to 2048 of secondary. 1 to 16 for cache memory. It is a drawback. Less memory occupying, but more memory occupying to transfer. But many operating systems are designed to enable the CPU to process a number of independent programs concurrently. This concept, called multi-programming, refers to the existence of two or more programs in different parts of the memory hierarchy at the same time. In a multi-programming system, when one program is waiting for input or output, there is another program ready to utilize the CPU. Multi-program means more than one program is going on. One program is waiting for input or output. There is another program ready to utilize the CPU. Computer programs are sometimes too long to be accommodated in the total space available in main memory. When the program or a segment of the program is to be executed, it is transferred to main memory to be executed by the CPU. It is a task of the operating system to main memory to maintain the main memory a portion of this information that is currently active. The part of computer system that supervises the flow of information between auxiliary memory and main memory is called memory management. The, the flow of information between the auxiliary memory and the main memory is called memory management system. What is the main memory? The main memory is the central storage unit in a computer system. It is a relatively large and fast memory used to store programs and data during the computer operation. The principal technology used for the main memory is based on the semiconductor integrated circuit. So main memory is a hardware device inbuilt, which type of means semiconductor integrated circuits are inbuilt manufacturing with this memory. And the random access memory is a part of computer of main memory, which is directly accessible by the CPU. And the integrated circuit RAM chips are available to two possible forms, static RAM and dynamic RAM. So RAM and ROM, two types of memories are there for the main memory. So RAM and ROM, there are two different types of memories are connected to the main memory. In the RAM, there are two types of RAMs are there. That is a static RAM and a dynamic RAM. So what is static RAM? It is consist of essentially of internal flip-flops that stores the binary information. The stored information remains valid as long as power is applied to unit. And the dynamic RAM stores the binary information in the form of electric charges that are applied to capacitors. The capacitors are provided inside the chip by MOS transistor. The stored charge on the capacitors tends to discharge with the time, and the capacitors must be periodically recharged by the refreshing the dynamic memory. So it is the DRAM cell and it is a typically SRAM. It is the internal manufacturing, how we are designing through the integrated circuits or through the circuit. Here word line, fast transistor, it is a capacitor, bit line is there. Here word line, VCC, bit line and complementary bit lines are there. So here more capacitors I am using, here less capacitors, here more capacitors needed. And what are the major differences of SRAM and DRAM? SRAM has lower access time, so it is faster. DRAM is higher access time, so it is slower than SRAM. SRAM is costlier. SRAM is costlier than DRAM. DRAM is cost is less compared to SRAM. SRAM requires constant power supply, which means this type of memory consumes more power. DRAM often reduces the power consumption due to the fact that the information is stored in the capacitor. More capacitors are there, then reduce the power supply. Here less capacitors, more power needed. Due to complex internal circuitry, less storage capacity is available compared to the same physical size of DRAM. Due to the less small internal circuitry in the 1-bit memory cell, DRAM, the large capacity is available. SRAM has low packing density. DRAM has high packing densities. And RAM is used to storing the bulk of the program and data that are subject to change. ROM is used for storing programs that are permanently resident in the computer. There are two types of memories are there, RAM and ROM. So RAM is a temporary memory. ROM is a permanent memory. And the ROM portion of the main memory is needed for storing an initial program called a bootstrap loader. The bootstrap loader is a program whose function is to start the computer software operating when the power is turned on. Since RAM is volatile and its contents are destroyed when the power is turned off, the content of ROM remains unchanged after power is turned off and so on. RAM is there when the power is off, the memory will be lost. When the power is off, also the memory will not be lost. And the startup of a computer consists of turning the power on and off, starting the execution of initial program, When power is turned on, the hardware of the computer sets the program counter to the first address of the bootstrap loader. And the bootstrap program loads a portion of the operating system from disk to main memory, and control is transferred to the operating system, which prepares the computer for general use. RAM and ROM chips are available in a variety of sizes. If the memory is needed for a computer is larger than the capacity of one chip, it is necessary to combine a number of chips to form the required memory size. So when I'm using 1024 into 8 memory, can be constructed with 128 into 8 RAM chips, 512 into 8 ROM. So it is a combination of RAM plus ROM is the main memory. So what is the RAM here means? Here I am taking example of 128 into 8. Here RAM is 512 into 8. If I are adding both, then only we'll get the main memory. And the ROM and RAM chips are better suited for communication with CPU. And if it has one or more control unit that selects the chip only when needed. Another common feature is a bidirectional data bus that allows the transfer of data either from memory to CPU during a read operation or the CPU memory during a write operation. A bidirectional bus can be constructed with a three-state buffer. A block diagram functional table of RAM chip is shown in below. So chip selection 1, chip selection 2, read, write 7-bit address. CS1, CS2 bar, read, write 87 means 0 to 7. So 8-bit of address line. What is the size means? 128 into 8 RAM. It is a 8-bit data bus. So 8-bit of data should be transferred from memory to CPU or CPU to memory. So how many chip selections are there? Total 2 chip selections. Chip selection 1, chip selection 2. For chip selection 1 is for read, chip selection 2 for write, like this. And if I am going for the chip selection 1, CS1, it is disabled, inhibit high impedance. When chip selection is 1 and it is 0, write operation. Chip selection is 1, both are 1, it is an inhibit. So 1 0, 1 0, then write. It is read, like this. Okay. The read and write inputs are sometimes combined into one line labeled read write. When the chip is selected, the two binary states in this line specify the two operations or read or write. There are two chip selections, CS1 equal to 1, CS2 bar equal to 0. If CS1 equal to 1 means automatically CS2 bar equal to 0, anything. And CS1 equal to 0, CS2 bar, the memory can be placed in a write or read mode. When the write input is enabled, the memory stores a byte from the data bus into location specified by the address input lines. When read is enabled, the content of the selected byte is placed into the data bus. The read and write signals control the memory operation as well as the bus buffers associated with the bidirectional data bus. It is about the ROM chip is organized externally in a smaller manner. ROM can only read. The data bus can be only in a output mode. The block diagram of ROM chip is here. There is no read write. Only read is there. So chip selection 1, chip selection 2, 9-bit address CS1 bar, CS AD9 512 into 8. The 9 address lines in the ROM chip specifies the 512 bytes of the stored. The two chip selections of CS1 equal to 1, CS2 bar for the unit operate, otherwise the data bus in the high impedance state. There is no need of a read write control because of the unit can only be read. Thus, when the chip is enabled by the two select inputs, the byte selected by the address lines appears on the data bus. Memory address map. The designer of a computer system must calculate the amount of memory required for the particular application and assigning it to either RAM or ROM. The interconnection between memory and processor is then established from knowledge of the size of the memory is needed. A memory address map is a pictorial representation of assigned address space for each chip in the system. To demonstrate a particular example, if a example computer system needs 512 bytes of RAM and 512 bytes of ROM because combination of RAM and ROM is a main memory, and it is the memory address map for the configuration RAM 1, RAM 2, RAM 3, RAM 4. Only one RAM is there. So if I am taking address process from 1 to 10, here taking, you can observe 000, 001, 010, 011. And the small x under the address bus line designate those lines that must be in the address input, and the RAM has 128 bits needed, and the ROM has 512 bytes needed in the 9 address lines. And it is now necessary to distinguish between the RAM chip by assigning to each in a different address, and the distinction between a RAM and ROM address is done with another bus line, that is choose line 10 for the purpose. When line 10 is 0, the CPU selects RAM. When the equal to 1, it selects the ROM. The first hexadecimal digit represents lines 13 to 16 and is always 0. The next hexadecimal digit represents lines 9 to 12, but lines 11 and 12 are always 0. The range of hexadecimal address for each component is determined from the X associated with each, and this X represents the binary number that can range from all zeros to all ones value. And memory connection to CPU, RAM and ROM, how we are connecting to the main memory. The lower order lines in the address bus select the byte within the chip, and the other lines in the address bus select a particular chip. And the connection of memory chip to the CPU is shown in the next figure. It is a configuration of memories consist of 512 bytes of RAM, 512 bytes of ROM, and here 7 low order bits of the address bus to select 128 possible bytes. The particular RAM chip selects the determining from line 8 to the 8 and 9 in the address bus. So it is here I'm taking 2 into 4 decoder to output of CS1 is the input of RAM, and when the address lines are 8 and 9, that is 00, the RAM chip is selecting 01, the ROM chip is selected, and so on. The read and write outputs from the microprocessor are applied to the input of RAM chip. The selection between the RAM and ROM averagely are achieved through bus line 10. The RAM is selected when the bit line is 0 and the ROM is bit line is 1. The other chip selection of input of the ROM is connected to the read control line, and the ROM chip is enabled by during a read operation. And address lines of 1 to 9 is applied to the input address ROM, and the assigning address 0 to 512 to RAM and 512 to 1024 to the ROM. And the data bus of the ROM has only one output capability, whereas the data bus connected to the RAM can transfer information in both directions. It is the memory connection to the CPU. Here I am taking RAM 1, RAM 2, RAM 3, RAM 4, but only ROM 1 I am taking. So all are for using for data transfer between the memory to CPU. It is the references. So up to now we discussed here memory organization. There are two types of memories are there. So primary memory and secondary memory. Magnetic tape, magnetic disk are the secondary memory or auxiliary memory. These are the types of memories: register memory, cache memory, main memory, magnetic disk, magnetic tape. Magnetic disk, magnetic tape are the secondary, and main memory is the primary memory. Cache memory is in between the connected to the CPU and main memory. So register means passing the information, passing the data between the memory to CPU, and it is the memory hierarchy in computer system. Auxiliary memory dividing as a two types: magnetic tape, magnetic disk. These two are connected to input output processor, and it is connected to the main memory. And the CPU cache memories are internally connected to the main memory. Here it is about the main memory and the cache memory. So if I'm using cache memory, the access time is 100 nanoseconds. And when I'm using main memory, 700 nanoseconds. When we are using auxiliary memory, 1000 times more need compared to main memory. And what is a block size means? The range is 256 to 2048 watts for auxiliary. And when I'm using cache memory, 1 to 16 watts are needed. So it is a multi-programming. And when I'm using the data transfer between auxiliary to main memory, that is called the memory management system. It is a main memory of two types: static RAM and dynamic RAM. It is about the static and dynamic RAM of with circuit diagram, and these are the differences of SRAM and DRAM. And it is about the RAM and ROM with bootstrap loader. It is a RAM and ROM chip selections, chip selection 1, 2 with the read and write operation. It is a chip selection of ROM with the read operation, and it is a memory address mapping. 1 to 10 address lines are there: RAM 1, RAM 2, RAM 3, RAM 4 with connected to the ROM. And it is a memory hierarchy, memory connection to CPU with the RAM and ROM. These are the address lines of RAM and ROM. It is the address bus CPU through the memory RAM 1, RAM 2, RAM 3, RAM 4 with ROM. It is about the main memory. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.